Questions 21 to 25 of the 2000 Grade 11 Fermat Math Contest. Two circles of radius 10 are tangent to each other. A tangent is drawn from the center of one of the circles to the second circle. To the nearest integer, what is the area of the shaded region? So let's connect the dots here and draw a triangle. And that will give you a pretty decent idea of what's going on. This is, of course, a right angle. And let's start labeling the radius. 10 here, 10 here, 10 there, and this is also 10. And then from here to here, we don't know, so I'll call that x. And therefore, we have a Pythagorean relationship. We have 10 squared plus 10 plus x squared is equal to 10 plus 10 squared, like that. So this becomes 100 plus 10 plus x squared is equal to 20 squared, which is 400. So therefore, 400 minus 100 is 300, is 10 plus x squared. And therefore, the square root of 300 would be 10 plus x. And therefore, finally, x is the square root of 300 minus 10. And if you do this in your calculator, you'll get about 7.32. All right, so we got x. Now, what I'm going to do next is figure out the area of that triangle. So the area of the triangle, of course, is 1/2 base times height. The base is right here, 10 plus x. So that's approximately 17.32. And the height is 10. It's right there. That's the height. So this is approximately 86.6. All right? Now, how do we figure out that shaded region? We figured out the whole triangle. Well, if we can somehow figure out the areas of these arcs, that one and this one right here, if we can figure out those arcs, we can subtract it from the full triangle and it will give us the area of the shaded region. So in order to do that, we need to figure out these angles, this angle and that angle. So let's call this theta 1 and we'll call this theta 2. All right? Okay. Running out of space here. Squeeze this. There we go. So now let's first figure out theta 1. I've got a triangle and I've got enough information to figure out theta 1 with sine. Sine of theta 1 would be opposite, which is 10 in that triangle, over the hypotenuse, which is 20. So therefore, the sine of theta 1 is equal to 1/2, and therefore theta 1 is equal to 30 degrees. And similarly, you can figure out theta 2, or you can just subtract it from 90 and 30 using the relationship that all the angles in a triangle are equal to 180. So 90 plus theta 1 plus theta 2, and then theta 1 is 30, so this becomes 180 is equal to 90 plus 30 plus theta 2, and therefore theta 2 is equal to 60 degrees. All right, so that is how we are going to proceed. Now, how do we figure out the area of these semicircular or arcs, these arcs that part of a circle? Well, this is how I'll explain it. So here we go. This is the diagram again. I wanted to bring it a little bit larger for you and help you understand how to figure out the area of these pies, I guess. It looks kind of like a piece of a pie, right? Right there. How do you figure out those areas? Well, we need the angles. And the good news is we found the angles. This one was 30 degrees and this is 60 degrees. So 30 degrees is that segment of the pie. So that means that this segment, the area, is going to be 30 over 360 times pi r squared. Because the full angle all the way around is 360, but we're only getting 30 of it. So that's how you come up with this part. And then pi r squared is the area of a circle. So this would be 1 over 12. And then r in this circle was, I believe, 10, correct? So there you go. You got 100 pi over 12, like this. And this is approximately 8.3 pi. In a very similar way, now we're going to figure out this pi piece right there. And that would be 60 over 360 pi r squared. And therefore this is 1 over 6 pi times 10 squared. And therefore this is 100 pi over 6. And that is approximately 16.6 pi. And therefore now we have everything. We've got the full triangle, which was right here. And we've got the two pi pieces. So now we can figure out the area of that shaded region. The area of this shaded region, let's clear this up a bit. So we've got area of shaded region, AS, is equal to the area of the triangle, which was 86.6, minus the area of these two pi pieces like that. And those two pieces we have figured out already. The first one is 8.3 pi, and the second one was 16.6 pi, like that. And if you do the math, you will get 8.1 approximately. And they have said, what is the area of the shaded region to the nearest integer? And that would be, of course, 8. So 21 is C. The leftmost digit of an integer of length 2,000 digits is 3. In this integer, any two consecutive digits must be divisible by 17 or 23. The 2,000th digit may be either A or B. What is the value of A plus B? All right, so we need to first explain what is going on. They have this very long integer. Very, very long. It goes on for 2,000 digits. Obviously, I'm not going to write them all out, but you get the point. And they've told you the leftmost digit is 3. So this is the leftmost digit. And they say that at any point, if you have two consecutive digits, that number will be divisible by either 17 or 23. So that number will be divisible by 17 or 23, and any of the multiples of 17 and 23, which are 34, 51, 68, 85 for 17, and for 23, 46, 69, and 92. And we don't need to be concerned with anything bigger because we're only looking at two-digit numbers. And then the very last, the 2,000th digit, the 2,000th digit is either A or B. And then once we figure out what is A and B, they want us to add it. Okay, let's go with this and let's see what we get. So now I want to place a digit there. What can I put as a number? Well, if I do, whatever number I create has to be divisible by one of these 9 numbers. So the only possibility is 34. So this has to be a 4. Correct? Because I've created a number, and any two consecutive digits must be divisible by 17 or 23. If I create a 34, it is indeed divisible by 34, which means it's divisible by 17. All right? Now, in the same kind of way, we will continue. The next digit, what can it be? Well, whatever I put there, that number has to be divisible by one of these 9 numbers. So the only choice is 46. So that's a 6. Now I've got a 6, and now I have to figure out what I'm going to put there. Whatever I put there, the number that is created must be divisible by one of those 9 numbers. So, but now I've got 2 choices. I've got 68 and 69. So let's start with 68 first, and then later we can figure out what happens with the 69. Now I have to put a number there. What choice do I have? Well, 85 is the only choice. So this is a 5. Therefore, this number here, what do I put? The only choice I can is a 51. So this is a 1. If that's a 1, then what do I put here? My only choice is a 17. So this is a 7. Now what about here? What do I put there? My only choice is, and I don't have a choice. There's no number in this list down here that starts with a 7. So I am done. I'm stuck. It ends basically there. So I have basically run into a dead end. That's okay. Go back to the drawing board and start over. It's important to know that dead end. All right, let's keep going. So we know that 3 is the first number. They told you that in the question. So let's keep going. Next number, I've only got one choice, 4. Next number, I've only got one choice, 6. Next number, okay, this is where the problem created. We had 2 choices and we chose 68, and that is what led to us getting stuck. So we certainly don't want to choose 68 again. We want to choose 69. So this will be a 9. And then what about this number here? Well, let's see. I think 92 is our only choice. And then what about this number? 2, 3. And then 3 would make us choose 34. Hope you're understanding how this is moving along. That number, the only choice I have is 46. And 6, okay. We gotta stay away from the 68. That is going to lead to a dead end. So we have to choose 69. So that becomes a 9. And 9 then gives us 2. And I think we're just repeating ourselves at this point. 3, 4, 6, 9, 2. 3, 4, 6, 9, 2. All right. So this 5-digit series just keeps on repeating until we get to the 2000th digit. So it looks like every time you have a digit that's a multiple of 5, what I mean by that in terms of its position, this is in the 5th position, right? This is the 10th position. It's always going to be a 2. So the 15th position, the 20th position, and so on. And if you get sufficiently close to 2000, the 1995 5th position, and finally the 2000th position is going to be a 2. Because 2000 is divisible by 5. So we figured out A. A is a 2. Great. But they're telling us that there's 2 possibilities. There's A and B. So what is B? We got stuck up here, and this one led to a 2 as our 2000th digit. So how are we supposed to figure out B? Well, what we can do is we can go to the 199/5th digit using this pattern and then switch to the top pattern. So watch what happens. So I've got my digits like this. This is the 991, 992, 993, 994, and 1995 digit. And it's the same pattern, 34692, 34692, right? It just continuing from where we left off. But now we've got the very final 5 digits, 996, 997, 998, 999, and finally our 2000th digit. And when we use this, we can get a value for B. So let's see what happens. We're going to start with 2. We have to put a digit there. If it's a 2, the only possibility is which one from that list? Hopefully by now you can figure this out. It's got to be a 3. Now how about this one? In order to make this work, we have to choose this one, 34. Now how about this one? It's got to be 46. Now how about this one? Now we have 2 choices. We've got 68 and 69. If we put a 9 there, then the very next digit will become a 2. And we've already got a 2 for A, so we want something other than the 9. We want this one, 68. And if that happens, then we can put this one, 85, like that. And therefore B becomes 5. Now you might say, wait, didn't you get stuck up there? Yes, I did, but I got stuck after the 7 right there. If you reach a 7, you're stuck, but doing it this way, we didn't reach a 7. We got to 8, 5, and then that's it. We're done. So this is a very good question, and if you do it in a systematic way like that, you should be able to get the right answer. Now, what are they trying to figure out? A plus B. So A is 2, B is 5, so A plus B is equal to 7. So the answer to number 22 is B. A circle is tangent to 3 sides of a rectangle, having side lengths 2 and 4 as shown. A diagonal of the rectangle intersects the circle at points A and B. The length of AB is. So I've blown this up a little bit, and let's start labeling what we know from this diagram. We know that this circle essentially has a diameter of 2, right? From top to bottom. That's the diameter, and it's 2. And therefore, the radius is going to be equal to 2, or 1 rather. If the diameter is 2, the radius is 1. And I'll just start labeling this to kind of make you understand, draw some lines, and just start labeling as much as we know. This is 1, this is 1, this is 1, this is 1, that's 1, that's 1, and so on. And I think that's it. There really isn't much else they've told us other than what we've already drawn. So let's concentrate, therefore, on what it is that they want us to figure out. They want us to figure out the length of AB, so this distance right there that I've drawn in red. And to do so, I'm going to concentrate on this triangle. A to the center of the circle, and then from the center, I'm going to draw a line like B to B. And that triangle is going to be at the heart of our solution. So the first thing I'm going to do is extract another triangle out of here, but I'll use a different color. I'll use green. This triangle right here. This triangle I'll draw over on the side. So it's the same triangle, but I just drew it on the side, otherwise the diagram would get quite messy. And I'm going to label it exactly the way I labeled it over on the other diagram. That side is 1, that side is 2. And then using Pythagoras, we can figure out the hypotenuse. Hypotenuse squared would be 1 squared plus 2 squared, which is 5, and therefore hypotenuse is the root 5, like that. All right? And at this point, I want you to figure out this angle right here, call it theta. You can use simple trigonometry, any one you want, sine, cosine, doesn't matter. You can use cosine. Cos of theta is equal to what? 1 over root 5, like that. And therefore, you can do this in your calculator. Theta will be equal to approximately 63.4 degrees. All right? So I'll now label the theta into this diagram. This is theta right here. All right? And then I need to then label this angle. Well, what is that angle? It's 90 minus theta. If I call that x, x plus theta is equal to 90, correct? Because that's a right angle. This one in here is a right angle. So x plus 63.4 is equal to 90, and therefore x will be 90 minus 63.4, which is approximately 26.6. Okay? Now, again, I'm going to extract a triangle from there because I don't want to mess this up. Because if you mess up the diagram, it becomes too confusing and then you just can't understand it. So this triangle that I wrote in here in red, I'm going to extract it and put it out down here. So I've got that one straight across, and I've got that. Okay, exactly what's in the diagram, I just drew it over here. I'm going to label this. This is x, and from here to here is 1, because that's the radius, and from here to here is 1. Look at the diagram very carefully. That's also the radius. And therefore, this is an isosceles triangle. I hope you're convinced of that. And therefore, this angle is also x. And this is A, and that's B. And AB is what they want us to figure out in the question. And how do you figure out AB? Well, you're going to use the law of cosines. And I hope you know what the law of cosines are. And this angle in here is 180 minus 2x. Okay, so there we go. I think we have everything we need. So the law of cosines, AB squared is equal to 1 squared plus 1 squared minus 2 times 1 cos of 180 minus 2x, like that. Okay? And if you're not familiar with the law of cosines, I can do a very quick primer for you. If this is a triangle, and this is C, and this is A, and this is B, and this is theta, C squared is equal to A squared plus B squared minus 2AB cos theta. All right? And that's exactly what I used over here with this triangle. So let's see what we have here. AB squared is equal to 1 plus 1 minus 2 cos 180 minus 2x. Well, x is that, so we can fill it in instead of keeping this 180 minus 2x. If x is 26.6, 180 minus 2x will be 126.8 approximately. All right, so now we can just do this. 2 minus 2 cos 126.8. Get out your calculator and you'll get, this is 2 minus 2 times negative 0.6 approximately. So this looks like 3.2 is AB squared. And therefore AB is going to be the root of 3.2. So it will be the root of 16 over 5, because 3.2 is 16 over 5. I just didn't want to get a messy decimal there. So this looks like 4 over root 5. And if you rationalize the denominator, multiply top and bottom by root 5, you get 4 root 5 over 5. 4 root 5 over 5 is AB. So let's see. 4 root 5 over 5, 23 is B. For the system of equations, this and that, the sum of the real y values that satisfy the equation is. So they want you to figure out all the values for y right there, and solving these two system of equations. All right, let's work through this now. So we've got x squared plus x squared y squared plus x squared y to the fourth is equal to 525. Okay? And we've also got x plus xy plus xy squared is equal to 35. All right, so let's tackle this one first. So x squared plus x squared y squared plus x squared y to the fourth is equal to 525. Now, just a little thing I wanted to talk about is these are equations, these are polynomials, quadratics, whatever. And if you manipulate a lot of these, you get a lot of practice, you'll be able to see little patterns and little tricks and things like that. If you don't know it, don't get discouraged. If you practice these, you'll see what those tricks are. And after you do several of them, those tricks will become part of your knowledge base. So in this one, there's a particular magic step, trick, whatever you want to call it. And it's like this. You have to add x squared y squared and subtract x squared y squared like that. And if you do that, you'll be able to factor things very well. This now, I will regroup as x squared y squared, like that. Bring this one up here, x squared y squared, and x squared y to the fourth. And then this one here will be left alone like that for now. The good news is, by doing that, we're able to factor this. This now factors into the following: x, y squared, xy squared, plus and plus. Okay? And therefore this becomes x squared y squared is 525. Let's move this up a bit. Now we have x plus xy squared all squared minus x squared y squared, like this, 525. And at this point, I hope you recall that if you have a squared minus b squared, that is equal to a minus b times a plus b. And that is what type of form that equation is in. So I hope you can figure out that that will be able to factor into the following. X plus xy squared minus xy, x plus xy squared plus xy. All right? So that is the full factoring of this. Now, one of these is very familiar because they've given that to you in the question stem. Which one was that? Right here. Right there. X plus xy plus xy squared is 35. x plus xy plus xy squared is 35. That is 35. So we can just substitute that in. We get x plus xy squared minus xy. And this is 35, like that. All equals 525. So then we solve for our only remaining x and y equation. 525 divided by 35, which is 15. All right, take a breather. We've gone this far. We can go a little bit further. So now what do we have? We have this equation here. And there's one equation that we still need to work with. It's the original one that I wrote up here. I used it recently, but we need to work with it again. X plus xy squared plus xy is equal to 35, like that. And these are our two equations that will help us solve for y. So I'll call this one equation 2, I'll call this equation 1, and I'll do 1 minus 2, like this. So 1 minus 2, x plus xy squared plus xy minus x minus xy squared plus xy is 35 minus 15. This cancels, this xy squared cancels, and you're left with 2xy is equal to 20, xy is equal to 10, and therefore we can isolate for x. X is equal to 10 over y. Perfect. And now we can take this value and substitute it back into any one of those and solve for y. I'll just use this one, equation number 1. So we got 10 over y, I'm substituting this into that, plus 10 over y, y squared, plus 10 over y, y is equal to 35. And let's see what this simplifies to. 10 over y plus 10y plus 10 is 35. Multiply through by y and you'll get 10 plus 10y squared plus 10y is equal to 35y, like that. And put everything on one side. 10y squared minus 25y plus 10 equals 0. There you go. I think you can divide through by 5. 2y squared minus 5y plus 2. I don't think this factors, so we have to unfortunately use our quadratic. That's okay. Minus b plus or minus the square root of b squared minus 4ac, like that, all over 2a. So this becomes 5 plus or minus the square root of 25 minus 16 all over 4. And this is 5 plus or minus the square root of 9, which is 3, all over 4. So 5 plus 3 over 4 is 2, and 5 minus 3 over 4 would be 2 over 4, which is a half. Okay, let's go back to the question and see what the question was asking. It was asking let me erase all this first. The sum of the real values of y that satisfy the equation. Okay, the sum of the real y values. All right, so our values of y are 2 and 1/2, so their sum is 2 plus a half, which is 5 over 2. There you go. So that would be 5 over 2 is 24 is E. The given cube is cut into 4 pieces by 2 planes. The first plane is parallel to the face ABCD and passes through the midpoint of edge BG. The second plane passes through the midpoints of AB, AD, HE, and GH. Determine the ratio of the volumes of the smallest and largest of the four pieces. So the first thing I have to do is explain this question in detail, and then we'll tackle it. So the first thing we need to illustrate is the diagram. So I'm going to concentrate on this cube and show you how this is being cut. The given cube is cut into four pieces by two planes. The first plane is parallel to the face ABCD. So that means it is exactly like ABCD, which is right here, ABCD, but it's below ABCD. Where is it? Well, they tell you that. It passes through the midpoint of edge BG. So the midpoint is approximately here. So this is the first cut, like here. All the way across, all right, like that. So that's the first cut, which essentially looks like it cuts the cube in half, with the top half and the bottom half. All right, that's the first cut. The second cut is with a second plane that passes through the midpoints of AB, AD, HE, and GH. So let's draw that, but let's draw that in a different color so you can see what that does. So we're going through the midpoint of AB and AD, so like that. And we're also going through the midpoints of HE and GH, so like that. So hopefully that's drawn pretty accurately. And we're going to slice all the way down. So when you do, you're going to meet the edges like that. All right, so you're making this slice, and then it's going to slice through the diagonal as well. So I hope you can kind of see what's happening here. And if you can't, I'll try my best to explain it further. So this is, first of all, the two cuts, all right? The two planes. The first plane that I drew in orange was the one that's parallel to ABCD, and the second plane that I drew in red was the one that passes through all the midpoints as given in the question stem. All right? So that is part one. So that's part one right there. Okay, now we get to part two. If you were to take a side view of this cube, just looking at the side, I'm just looking at the side, and this cut was being made all the way down like this. This cut, that's the first plane, and this is the other plane. This plane, of course, I drew in orange, so I'll draw it in orange over here, like that. There you go. And the other plane I drew in red, so I drew it in red here. This is sort of a side angle. That's how it's being cut into four pieces. So it says in the question stem, four pieces. So we'll label this S, L for small and large, because that's how they label it. And the other two are exactly the same. This is also S and this is also L. All right? So I hope you're convinced of that. All right, so here we go. Now we're at step number 3 of this question. Now, when you take the first plane that I've drawn in orange and you cut the cube, essentially you sliced it in half, what is the volume now? Well, the volume is length times width times height, correct? Well, the question tells you that the given cube, does it give you any dimensions? The given cube is cut into 4 pieces by 2 planes. First plane, second plane. No, it doesn't. So it's okay. We can introduce some simple numbers. Let's just say 2. Let's say the edge of the cube is 2. All right, like that. No problem. That's perfectly allowable because in the end they want us to figure out the ratio. So what we call it, it won't matter. So now I want to figure out the volume of not the full cube, but just the half of it. Just that part there. So if I were to draw a 3D, it would be like this. My cube's been sliced in half. So this is 2, but this is now 1, right? And this that I little chopped section that I drew represents the bottom half. And therefore that volume should be pretty easy to figure out. 2 times 2 times 1. So that's 4. So that means if you're looking at this, that L plus S is equal to 4. All right, the large piece and the small piece are equal to 4. That's very important. That's going to come back later in the question. And before we proceed, let's not forget what we're trying to figure out. Determine the ratio of the volumes of the smallest and largest of the 4 pieces. So they want us to figure out, find S over L, that ratio. All right? You ready for the next step? Okay. Here we go. Now the next step is I have to draw S. This S that I'm trying to figure out, I have to draw it. And once I draw it, I have to then figure out the volume. And then I can use this formula to calculate L, and then I can figure out the ratio. So the next step is to draw S. So here we go. Now before I draw S, I want you to understand that in this one here, this is S and this is S, right? There's 2 S's, but they're both the same. So if I draw this top one, it's like pretty much like I'm drawing the bottom one. And I'm going to draw the top one for you. And I'm going to draw it by using this diagram. And I'm going to draw this diagram again and explain it a little bit better than this plane dissection so that you can understand exactly what S is. So here we go. We have to draw S now. So let's make that second and first plane cut. So the first plane, if you remember, it was just basically cutting the cube in half like this at the midpoint. So that's pretty straightforward. That's probably the easier one to understand. Okay, so the first plane just sliced the cube in half at exactly the midpoint of BG, which is right there. All right, now we have to draw the first cut, or the second plane, which is from the midpoint of AB to AD, the midpoint of GH to HE, like that, and it's essentially going to cut like this all the way across. All right, so I'm just concentrating on the top part, and that top part is going to be my S. So let's see if I can shade it. So this is my top part. That part is my top. This part is my base. And these are my sides. Right there. Okay? That is my shape. That is S. Now, don't worry if you're looking at that and you're thinking, what on earth shape is that? I have no idea how to figure out the volume of this. You want me to figure out the volume of S, but I don't know what shape this is. And trust me, I don't know what shape it is either. So what we have to do is we have to make it into a shape. And how do we do that? Well, this is the point of the question that is the key. is you have to extend these lines right here. And if you extend these lines right here, like that, it becomes a, does anybody know what shape this is? This is a tetrahedron. There you go. So it is a tetrahedron. All right? And we can figure out the volume of that. Volume will be 1/3 times the base times the height, h. All right? So here we go. Do we have all the values that we need? Do we have all the values for base and height? Base we do, right? Because this is the base right here. This is the base of this tetrahedron that I've drawn in blue. And we have this part is 2 and that part is 2. They're just sides of the cube. So the base we do, we have 1/3. The base is a triangle, so it would be 1/2 base times height. So 2 times 2, like that. Okay? The height, however, is something we have to figure out. The height of this tetrahedron is this guy right there. How do we figure that out? Well, the good news is that we have a little bit of that information. If we use similar triangles, we can figure out the rest. From the very top till here, right there, I'm going to call x. So this part here, I'm going to call x. And then from here to here, I know that already, and you should too, it's 1, right? Because that first plane cut it at midpoints, so that's 1. And then similarly, from here to here, I know that is also 1. And I know that from here to here is 2, and that's already labeled. So using similar triangles, x over 1, this x over this 1, is equal to the full height top to bottom, which is x plus 1, over this full base, which is 2. All right? And then if you solve for this, you get 2x is equal to x plus 1, and therefore x is equal to 1. Great. Simple number. So now we have the height. The height is the full from the top all the way to the bottom. And that looks like 1 plus 1, so that's 2. So therefore this becomes 8 over 6. And that is the height of the total tetrahedron. But remember, S is not the total tetrahedron. S is just the part that I highlighted in this shaded red. Remember I was doing that? And then I had to add a top to make it a tetrahedron. So if I can subtract that top, this top here that I drew in, if I can subtract that top from the total that I just calculated, then I can figure out S, and we will be in business. All right, so we are almost done. So now this was total, V total, total volume, and then I just have to figure out now the top volume, which is the part I shaded in green. All right, same formula, 1/3 base times height. 1/3, the base is a triangle. It's 1/2 base times height. It looks like 1 times 1. And we've labeled that in there already. The height we calculated already is 1. So therefore this becomes 1 over 6. So perfect. The volume therefore of S, our S that we are trying to figure out, is the total volume, which is 8 over 6, minus the volume of that top part I shaded in green. And therefore this is 7 over 6. Perfect. We have one final step remaining and we will figure this out. Step 7, or what number are we up to now? Step 4, step 5 actually. Or step, whatever, it doesn't matter. It doesn't matter what step. We'll just call it last step. How's that? I think that's the perfect thing to call it, last step. All right, here we go. So now let's refresh our memory as to what it is that they wanted. They wanted us to find this, right? S over L. And we also know that L plus S is equal to 4. Okay, so they want S over L. And we also figured out that L plus S is equal to 4. All right, great. So this was S, right? So that means L plus 7 over 6 is equal to 4. So L is equal to 4 minus 7 over 6. So this looks like 24 minus 7, 17 over 6. All right? And therefore, finally, S over L, 7 over 6 over 17 over 6. Invert and multiply. And we'll get 6 over 17. And finally, we have 7 over 17. All right? So that is 7 over 17 is 25 is D.